Next, let's go to the metals. Conclusion. Metals completed, non-metals completed. So I am going to explain some exceptional cases. Those are all metals except mercury, those are solids at room temperature. What is the meaning of this? Most of the metals are solids except mercury. Mercury is a liquid metal at room temperature. We know that metals have very high melting points. Most of the metals are high melting points and boiling points. But in the case of gallium and cesium, they are low melting points. When we keep this gallium and cesium and keep on palm, then they will melt easily. The melting point is very, very less. That is gallium and cesium. They have low melting points. These two metals will melt when we keep them on your palm. So this is about the metals exceptionals. First, what I am telling, all metals are solids except mercury. Most of the metals are high melting points and boiling points except gallium and cesium. They are low melting points and boiling points. So exceptionals we have to remember. Next, iodine is a non-metal, that is lustrous nature, that is I explained. Alkali metals, lithium, sodium, potassium, these are the soft metals. Generally metals are hard in nature, but lithium case, sodium, potassium case, those are soft metals. They can be easily cut with your knife and they have low densities, low melting points. These are the exceptionals. Lithium, sodium, potassium are soft metals. The remaining metals are hard metals. Carbon is a non-metal and can exist in different forms. Each form is called as allotrope of diamond. So what is allotrope? The same element exhibits more than one physical form. That means same element exhibits different forms. Same element exhibits different forms. That is called as allotrope. Suppose diamond is made up of carbon, graphite is also made up of carbon. Same element in diamond, graphite, but different forms, different physical forms. That is called as allotrope. Allotropes of carbon, diamond, carbon. So next one. Explain the meaning of malleable and ductile. So explain the malleability and ductility. Already we discussed about the metals malleability. Most of the metals are malleable in nature. Metals can be beaten into sheets. So here malleability means the metals can be beaten into sheets with the hammer. For example, a piece of aluminum metal which is taken and beat it with a hammer 4 or 5 times, we will find the piece of aluminum turns into thin aluminum sheet. So this is called as aluminum foil also. You may call it as aluminum foil. So without breaking. Ductile means the metal can be drawn into wires. For example, gold, which is the most ductile metal. 1 gram gold that can be drawn into very thin wires, about 2 kilometers. 1 gram gold you can drawn into 2 kilometers. So that is about the malleability and ductility. Gold you can do, and also you can do with malleability, you can do with ductility. So this is about the activity, malleability and ductility. Next one. To show the metals and non-metals react differently with oxygen. See, take a small piece of magnesium ribbon. See, I am taking magnesium metal. Magnesium burns in the presence of oxygen and produces white dazzling flame. White dazzling flame means a brilliant white color. Then after that it forms ash of magnesium oxide. See, magnesium burns in the presence of oxygen and produces white dazzling flame. After that, magnesium oxide. This is the ash of magnesium oxide. Ash of magnesium oxide. See, after that, in order to balance this reaction, left side 2 oxygens are present, right side only 1 oxygen is present. So you should balance this. Left side 1 magnesium is present, right side 2 magnesiums are present. So 2 magnesiums are there. So you should balance this. So 2 Mg plus O2 gives rise to 2 MgO. So first what you observed? White dazzling flame when magnesium burns. Second one is ash of magnesium oxide. Next, this magnesium oxide react with the water to form magnesium hydroxide. This is about magnesium. Second one is sulfur. Sulfur burns in the presence of oxygen to form sulfur dioxide, SO2. Sulfur dioxide. The produced sulfur dioxide again react with water and forms sulfurous acid, H2SO3. So this is in acidic in nature. This is acidic in nature. This is in basic in nature. What is conclusion here? Metals are produce the basic nature, non-metals are acidic in nature. Okay, these are the equations. Magnesium reacts with oxygen and forms magnesium oxide. Formed magnesium oxide react with water and forms magnesium hydroxide. Magnesium hydroxide is a basic in nature. That's why red litmus paper is dipped into the magnesium hydroxide solution to form blue. That means red litmus turns into the blue litmus in the presence of basic medium, because metal hydroxides are basic in nature. Metal hydroxide means what? That is magnesium hydroxide. If metal is present or OH minus ions are present, that is always basic in nature. That's why red litmus turns into blue litmus. But blue litmus does not change any color, does not show any color. Here, let's go to the next topic. Take a small amount of sulfur powdered in a deflagrating spoon and start burn. This also I explained. Sulfur reacts with oxygen, forms sulfur dioxide. The produced sulfur dioxide reacts with water to form sulfurous acid. Then this is blue litmus turns into the red litmus. Because of that, sulfurous acid acts as a acidic in nature. So this is about sulfur reacts with oxygen, sulfur dioxide. Sulfur dioxide reacts with water and forms sulfurous acid. Blue litmus changes into red. So acids, blue litmus changes into red litmus. Bases, red litmus changes into blue litmus. So this is about non-metals. I completed non-metals. Okay, thank you. So I am giving homework. You should complete this concept 2. You should read this part. Everyone should read and come to the class. I'll ask the questions tomorrow. You have to complete and come to the class.